Hello everyone, so today we are going to solve another interesting problem number 1838, frequency of the most frequent element. And the problem says we have been given an integer array nums and an integer k, and we can perform one operation in which we will choose one index from the nums and increment the element of that index by value 1, and we want to return the maximum possible frequency of an element after performing at most key operations. Okay. So what we have been given is we have been given 1 to 4 and we have been given k equals to 5, and we can add increment values at any index. So if I choose index 1 and incremented value by uh, let's say 3, and so it becomes 4, and similarly if I choose the two index 1 and incremented value by 3, so I have exhausted from 5 first 3, and from 3 I have exhausted 2. All the remaining uh, so I have exhausted 3, so it becomes 2. Now I have exhausted all the 2, so it becomes 0. So this becomes 4, and other this was originally 4, so now the frequency of the most frequent character, which is 4 in this case, and the count of that is 3, and this is what we want to return in our case. Okay, so what I observed that, like, if I solve this problem, how I would handle is, so I will keep two pointers left and right to keep the track of the window in which I am, and I will expand this window or shrink this window based on one observation. So my observation for this problem is that at any given index r, what I will do is I will calculate that until that position, if all the elements are of same value, and I can sum that all elements, and what is the maximum sum that I can get via that, and the maximum sum that I can obtain till the index r by doing key operations. So if I write that out, so on the left I will sum that if all the numbers or element between L and R, basically left and right pointer, at the index R of same values, then the maximum sum that I can obtain, and the maximum sum on the left I can obtain. So what I mean by this is, let's say if I'm at index R, which is at R is equals to 1, and if all the elements between L and R are of value 2, then the maximum sum that I can obtain on the left hand side is basically 2 into 1 minus 0 plus 1. This is the window length, and at this position the maximum sum after maximum sum is 1 plus 2, which is, and if I do the key operations till in these, then the maximum sum is 2 plus 7, 5. So on this basis, what I will do is I will expand and shrink my window. So if this condition is true, then what I will do is I will um, then I will increment my uh, shrink my window of L and R. Otherwise, I will just keep expanding my window in which I am doing the operations, and in the end I will return the maximum length that I have seen of the window that I've been working on. So if I write out this algorithm for you, so what I would be, so if I will start from the start, so if we have 1 2 4, and we'll place two pointers left and right, So when r is 0, at this moment the sum is prefix sum is 1, and the the sum of the indices, sum of the elements till the index r of value 1 is basically 1 into 0 minus 0 plus 1, and the maximum sum on the right is 1 plus 5, and clearly this condition is false. So we'll again increment, we will expand our window at this point, and now we'll check if my if all the elements till the index r equals to 1 have been 2, then the maximum sum that we can obtain at this point is 1 minus 0 plus 1, and this is 3 plus 5, which is 8. And again this condition is also false, so we'll again expand and make all the elements in the original list of value 4 and see how what is the maximum sum that we have obtained so far. So if all the elements in the array are of value 4 and this uh, length is 2 minus 0 plus 1, which is 12, and the prefix sum of all the values till the index r is index 2 is basically 1 plus 2 plus 4, which is 7 plus 5 is equals to 2. So these two are matching at this point. So this is the most this is the point in which we'll have the element of maximum frequency, and this length of window we want to return. So which is 2 basically at this point, which is basically 3 at this point. So which is 2 minus 1 plus 1, 2 minus 0 plus 1, so that is 3. So this is the approach and algorithm, and now let's get into the coding part, which will become more clear once I write the equation, once I write the algorithm for you. So what I will do is, first I will for the very first time I will sort this nums list so that the elements don't get we don't get a minima in between, and we'll keep two pointers like we discussed and one some value. So that would be one some value at s variable and one left and right. So for right I will use just a simple for loop. So for r comma number in enumerate, so I'm keeping the index and the values simultaneously, and I will calculate the prefix sum by adding the position index by adding the value at any index r into the prefix sum. And now we'll calculate our logic that if all the numbers still if all the values if the values in the in the original list are of uh, same value of index r, then what is the maximum sum that I can reach at this point is basically number minus number into the length till between L and R pointers where I'm, and I will compare with this with the maximum sum that I can obtain. And if this condition is true, then I will shrink my window, so which is just will bring our window from left to right, and will increment the left pointer, and in the end otherwise we'll keep expanding the window, and this is the window length that we want to grab at this point, so which is maximum of answer and the window length that we have. And in the end we will just want to return this answer that we have found, basically the window length, and this would do the job. And let's run our solution and see how it performs. Local variable answer is cannot be accessed. Oh, we have to declare, I forgot to declare the answer variable with the initial value. So that has been accepted for all the example test cases and submit our solution. So it is the best solution, algorithmic solution that we have over here. And coming in terms of time complexity wise, so the time complexity is O of n log n for the sorting part, and for the sliding window part it is O of n, and space complexity is O of 1 because we are just using one variable s to compute the sum. So I hope you guys are liking my solution. If you have any particular problem that you want me to solve, please let me know, and I will see you tomorrow with one new algorithmic problem. And please like and subscribe to the channel. It helps me motivate, it keeps me motivated to create such more awesome content for you guys. Thank you and have a nice day.